theory. So what is set? What is set? Set is collection of objects. Okay, any collection. Set is structure representing an unordered collections. Why unordered? What is ordered collection? Ordered collection means if AB and BA both are different, then that is called ordered selection. But in set, AB and BA both are same, that's why it is unordered collection. Okay, group or plurality of 0 or more distinct objects. What is 0? 0 means no elements or phi. Okay, set theory deals with operations between relation, among, and statement about sets. So in set theory we do operations on set. Okay. So set theory, set build. So there are two notation. One is list notation, for example ABC, and second notation is set builder notation, for example this X, where Px is this. For example, if I will write only this notation 2, 4, 6, 8, 10, 12, so that also we can write. And another thing, X or 2x, x is greater than 1 and less than 13. So both are same thing. Okay. It's clear? So sets are inherently unordered. Unordered, I have already told, ABC and ACB both are same. Distinct? Yes. So if we write AA, BA, BCC like this, this is called, if it is, this is called multi-set, where multiple elements are possible. But in set, there is distinct element only. Two sets are declared to be equal if and only if every elements are same. Okay. So for example, 1, 2, 3, 4 is equal to x is an integer where x is greater than 0 and less than 5. Okay. So these things are basic, you know already. Conceptually sets may be finite and infinite. Okay. So there are two different set. One is finite set and another is infinite set. So anything else? Are all infinite sets are same? For example, one set is this one, 1, 2, 3, 4. For example, one set is 1, 2, 3, 4. If I have finite element, that is one set. And another set is 1, 2, 3, 4, all, for example, this natural number. One more set, that is called real number. Are this infinite and this infinite are same, or there is any different? Means both are infinite only, but is there any difference, or both are? Okay, first, yes. This is a number.
That is a collection of numbers.
Yes.
But that infinite thing is, it is a number itself.
Okay, that is okay. This is a number. That is correct. That you are correct. But if I am telling that there may be one set of real numbers also, then means if I am doing this thing, 0, 0.1 means 0.1112, all these things if covers, means that is denoted by R, means R is not only this number, means I am telling that all real numbers are there, and means Natural numbers. What is natural numbers?
Starting from 1.
Starting from 1. Yes, correct. Yes, yes, you are right. It should not. And what is whole number?
Starting from 0.
Starting from 0. And Z means integer. Okay, maybe positive or negative integer. Okay, now maybe it is in, let us set. So there are many Venn diagrams that you already know. Empty set you have seen. We later come in that slide again for cardinality. What is cardinality? Do you know? Cardinality means number of element in that set. Okay, so when we go through that slide. So this thing is empty set, you know, phi having 0 element. So what is cardinality of empty set? 0, no element. It is okay. Subset and superset notation. This is called subset. S is subset of T. Okay, if all elements of S is present in T. So this is something like this, that you know. Similarly, superset is opposite of that. Now, yes. What is proper subset? Proper subset means a subset, but here what is the condition? Here equal to condition is also there. Proper subset means this equal to condition will be not there. This is called proper subset. Means it cannot be same. For example, 1, 2, 3, 4 is a set, then 1, 2, 3, 4 is also subset of that, but 1, 2, 3, 4 is not proper subset. Okay. So it is possible that set of sets is also possible. Okay. Now cardinality and finiteness. Yes. What is cardinality? Means number of element in a set. Okay. So for example, cardinality of phi is how much? 0. Cardinality of this set is 3. Cardinality of this set is 2. Like this. Okay. Now one important thing before that. Cardinality of n, z and r. N means natural number, means 1, 2, 3, 4. What is cardinality of n? That is infinite. And what is cardinality of r? Number of element. R means number of real number. That is also infinite. Correct, you are right. But there is a difference. Actually, sets are two types, finite and infinite. And in infinite there are two types, can be mapped to natural number and can be mapped to real number. There are two different types of infinite. Why there are two different types of infinite? When we see natural number means 1, 2, 3, 4, this. Here you can see the gap is also fixed, finite only. But if you see real number, what is the gap? 1. Now 1 to 2, there may be infinite numbers, maybe 1.1, maybe 1.2, 1.3, like infinite numbers are there, 1.11, 1. Okay, so actually here cardinality is infinite cross infinite. Here cardinality is infinite. The difference is clear. In TOC this thing will be used, this difference. Infinite cross infinite is also infinite, but it is more than infinite. For right now you will understand this. When we read theory of computation, that time you will understand that both are not same. Right now you just understood this, that definitely this thing, number of natural numbers and number of real numbers are not same. there we learned that number of, in TOC we learned that number of machine, means Turing machine, or number of machine and number of language, both are not same. And one thing is equivalent to natural number, one thing is equivalent to real number. How? So you cannot map for every language, you cannot make a machine. Similarly, for every machine you can make language, for every language you cannot make machine. So why that thing is, means why there is gap, that for understanding those you should understand the difference between cardinality of natural number and cardinality of real number. So you must understand that real numbers are far bigger than natural numbers, because for every gap, means 1 and 2, there are infinite numbers in natural numbers. So definitely number of real numbers are very big. What about integers? Integers will come here or infinite. Okay. What about fractions? It looks like infinite cross infinite. Okay, it looks like that, but there is one mathematician that is called Turing. He proved that no, that is equivalent to, means it will come here only. Okay, so later we will understand that how it will come, but at least you understood that integer is in natural number and most of the things are in natural number other than the real number. Okay, clear? Power set. What is power set? Power set is set of all subset. For example, if this is the AB, then what is power? How many subsets are possible? Phi is subset of every set A, B, and this. This is called power set of this, and this can also be written like 2 power p. Okay. One important thing is there. If we write 2 power p, what is meaning of this? This is a number. So if 2 power p means 2 power 2, so you can say 4. But if it is written like this only, it means it is a set. Okay, and this is power set. Is it clear? Now can you tell me how many, if there are n elements, for example, if there are 4 elements, how many elements are there in power set?
16.
Correct. And similarly, if there are n elements, then how many? 2 to the power n. Okay. Now, if there are 4 elements, okay, how many subsets are possible of 2 elements? 2 elements means like A, B, B, C, B, D, like that. How many subsets are possible for this? Actually, what we are doing, that you have to understand. We are trying to choose from these 4 elements, we are trying to choose 2 elements, and their order is not important. Means order is not important, means AB and BA both are same. So how many elements are there? From 4 elements, we are trying to choose 2 elements. So this is how much? Factorial 4 divided by factorial 2 and 2. So this is 3 into 4 divided by 2. So 6. Is it clear? This thing is clear, that here combination will be used. Okay. Now our first question is there, that if there are 4 elements, how many total subsets are possible. So how many total subsets are possible? 4C0 plus 4C1 plus 4C2 plus 4C3 plus 4C4. So can you tell me what is the summation of all this? You have already told.
4C0 is total 16.
There is one formula, binomial formula. A plus b raised to power n is what? nc0 a raised to power n plus nc1 a raised to power n minus 1b plus nc2 a raised to power n minus 2b square. Similarly, ncn and b raised to power n. This you know. Okay, for example, if I have to write a plus b raised to power a plus b cube is how much? A cube plus a square b plus ab square plus b cube, and here it will be nc0, so it is 1, 3c0 is 1 and 3c2 is 3, and this is b cube. Okay, that you know. Now if you put here also 1 and here also 1, what happened? 1 plus 1 raised to power n equal to how much? All these things will be 0, so this will become nc0 plus nc1 plus nc2 ncn. Okay, so now, so this is how much? This is 2 raised to power n. So 2 raised to power n equal to what? nc0 plus nc1 plus nc2 till ncn. Is it clear? So here what we are trying to find, 4c0 plus 4c1 plus 4c2 plus 4c3 plus 4c4. So this will become how much? So this is how much? 2 raised to power, yes, 16, 2 raised to power 4. So that's why total number of element in power set is how much? So you write down this result. Total number of element in power set, or you can say cardinality of power set, equal to 2 raised to power n, and that is equivalent to nc1 means nc0 plus nc1 plus nc2 to ncn. And that is equal to nc0. Why I am focusing in this nc0, nc1, nc2? Because nc0 means what? Number of element with 0 element, number of subset with 0 element. What is nc1? Number of subset with 1 element, number of subset with 2 element. Similarly, number of subset with n element is also 1. Is it clear? So this is subset and power set. Both are clear? This is very important result, because there are many repeated questions, okay, based on this. And this is very obvious that number of element in power set is greater than n always. Okay, clear? Ordered and tuple. Okay, so there may be ordered tuple also. That is part of when this we can leave, right? Cartesian product. Okay, now it will come to this. What is Cartesian product? Cartesian, if there are two sets, for example 1, 2, 3 and another set is AB, then what is product of both? 1A, 1B, 2A, 2B, 3A, 3B. Okay, so that is called product of two sets. Oh, here also this one. Now one important thing is that Cartesian product is not commutative. means A cross B is not equal to B cross A. Why? Because it is ordered tuple. Here actually the focus of written ordered tuple means what? Ordered means when ordered is important. Ordered is important means 1A is not equal to A1. So that's why this ordered tuple came. Ordered n tuple means it may be Cartesian product of 3 number of sets. Means A, B and C, there may be 3 sets. Okay? Is it clear? So Cartesian product you understood. It is not commutative, that also you understood. Union operation. Union operation, you know what is union? Means it is first element also and next x, where x is element of A or x is element of B. That you know. So one example is 2, 3, 5, 3, 5, 7. So union is, so actually union is 2, 3, 5, 7. Okay. That you. Intersection similarly you also know. So this thing is clear, intersection is clear. Now what is disjoint set? Two sets are disjoint if their intersection is 0 or phi. So A intersection B is phi, then you can say that two sets are disjoint. Okay. Now, okay, one important thing is inclusion exclusion principle. What is inclusion exclusion principle? Okay, before set difference. What is inclusion exclusion principle? What is number of element in A union B? Number of element in A union B equal to number of element in A. This thing is clear, that what is this? This is number of element in set A. So you can say cardinality of set A or number of element in set A. This is a representation of that set. For example, what is this? 0. So now, so number of element in A union B equal to number of element in A plus number of element in B minus A intersection B. This is clear? Okay. If you extend this, what happened? Number of A union B union C is equal to what? Number of element in A plus number of element in B plus number of element in C minus A intersection B minus, correct, B intersection C minus C intersection A. Anything else? Plus A intersection B intersection C. Okay. Now why it is like that? First try to do this. What is A union B? So A, when we are finding A union B, we are finding all elements in this. So when we are adding this A and we are adding this B, what happened? This portion is added twice. So that's why we have subtracted this. Okay. Similarly, when we try to find number of element in this A union B union C, this, what happened? First we added all these. So when we added all these, this element is added more twice. So that's why these elements are subtracted. But when we are subtracting 3 times, this elements are subtracted this. That's why we have to add it. This concept is clear. This thing is called inclusion exclusion principle. What is inclusion exclusion principle? When we have to find A union B, first you have to include all these things means A plus B, after that exclude that. And if there are 3 elements, include that, exclude that, again include that. If there are 4 elements, similarly you have to do this thing. Okay, and now because you know that how many elements are in subset of that, so you can easily say that how many elements are there. For example, if I have 10 elements, means if I will see A union B union C union D union E, if there are this, and I want to calculate that how many elements are there like this, subtracted A union B, sorry, A intersection B minus B intersection C, like that, how many elements are there? Can you tell me?
10.
How it is 10?
Like A intersection B.
Yes, so how you count all these elements? Actually you have to count.
Each is coming to 10.
No, actually you have to count from all these 5, you have to count, you have to choose 2 elements. So it is 5C2. So how much it is? 5C2, just calculate. You are right, actually it is 10 only. 4 into 5 divided by 2, so 10 only. But what if I will ask with 3 elements? Means how many elements with 3? Means after minus, again this will be A intersection B intersection C, like this will be. So how many terms are there? Yes, so that is actually okay. So you are calculating like that. Yes. So 5C3. Okay. So 4 into 5 divided by 2. So yes, 15. Is it clear?
No, it is coming 10.
No. Here I have. Yes, 4 into 5 divided by 2. So it is 10 only. No, not 15. It will also 10. 5 choose 3. Means from 5 elements we have to choose 3. For example, A, B, C, B, C, D, like that we have to choose. So how it is chosen? From 5 elements we have to choose subset of 3 elements. So factorial 5 divided by factorial 3 into factorial 2. So factorial 3 will be cut into 4 into 5 divided by factorial 2. So this is 10 only. You can check it. Means if you write number of elements, it will take more time, but there will be 10 elements only. Okay. So this is clear? Any doubt? So this thing is, this you already understood that this portion, which is intersection portion, you have to subtract it, and because here we have subtracted it more, so we have to add it. So that is inclusion and exclusion. Now set difference. What is set difference? A, for example, if it is A and it is B, so what is A minus B? This portion. Okay. Any doubt? Now A minus B is a, till now A union B and A intersection B, both are what? Commutative. Means A union B and B union A, both are same. What about subtraction? A minus B and B minus A, both are same or not? Both are different. Clear? So there is a symmetric difference. So set difference you already know. So set complement also you know. What is complement? Universal set minus these things. Okay, before that, it is not written here, so I will do here. So this is not a symmetric one. So that's why there is one more operation that is called symmetric difference. Symmetric difference. What is symmetric difference? A XOR B, okay, that is equal to A minus B union B minus A, and that is same as A union B minus A intersection B. Okay, how can you understand that both are same, or it looks different? Okay, so try to make yourself Venn diagram. Try to make yourself Venn diagram. A and B. So what is A minus B? This portion. Correct? What is B minus A? This portion. Is it clear? Now look at this. Second, this is also A union B minus intersection portion. Is it clear? So both are same. Now this operation is symmetric. This operation is symmetric. A minus B union B, and this is same as B XOR A, or B symmetric difference A. Clear? Now you just think this operation and XOR operation of digital logic, or in there also we have seen in discrete maths also we have seen XNOR. So just opposite of this is this. Is it clear? So this is when both are different. Actually this is sum, A and B. So you can say that symmetric difference also and symmetric sum, that is also same thing. Symmetric difference and symmetric sum are same. That is A minus B union B minus A, or A. Okay. Set complements, you know. Now set identities, some identities which is same in discrete maths, there we have not covered. So you can see here, if you do union with phi, that is A, okay. Similarly this union with universal set is always this, intersection with phi is phi. Idempotent law, that is also means with same you are doing intersection or union, there is no. Double complement, that will give commutative. Associative, what do you mean by associative? Means changing bracket will not change the thing, it will remain same. Means you can change the bracket. Means commutative means changing position, means A union B and B union A. Yes. So commutative means you have to replace A with B. If both are same, then you will say that that is commutative. And for associative, you have to take three things and then you have to check with this. Okay? Clear? De Morgan's law, you know. Proving set identities, okay. Yes, like truth table, here also there is table. Using table you can say that some sets are equivalent or not. Here also you can make, means if elements are present then you make as 1, if elements are not present then you make as 0. So like that you can create a table and then you can prove anything. This is which thing? Which law? This is called distributive. Okay, why distributive? Why it is called? Because this thing is distributed in both of them. Intersection is distributed here also and here also. That's why this is distributive. There, this is same as AB plus AC. So multiplication is distributed over plus. Is it clear? Associative is what? Associative is A, B, C equal to A, B and C. This is called associative properties. These two things are important. One is associative, another is distributive, and one more thing is, maybe it will be there in, or no. One more thing is, what is A intersection A union B? What is value of this?
A intersection A means A.
Yes, so what is value of this whole thing? A. Okay, what about this? No. Do using Venn diagram? Yes, A. Is it clear? So this thing is called absorptive property. This is also important. Although there are many things, identity, domination, there are many things, but these three are very important. One is associative, second is distributive, and third is absorptive property. So for example, this is also A plus B dot C is how much? Sorry. No, means if BC, then there is, yes, A plus A dot B, yes. If there is BC, then the result is not. In digital logic, yes. So this is how much? Correct. Similarly, A dot this is how much? Yes, so A dot, you can think like this also, A plus AB, because A dot A is A square plus AB. Again this, so both are A only. Is it clear? Any doubt?
No, but how that
A dot A is A dot A plus A dot B.
Okay, A dot B is
A dot A is A.
and A dot B is
No, not 0. A plus AB only. Now this A plus AB is, and how this is A you take common, 1 plus B. 1 plus B is what? 1 only. So A dot 1 equal to, like that also you can think, but you always remember, actually what I want to tell, that these are more basic, means this is absorptive property, and when we are going to set theory, means we will go to set, relation, function, and after that we will go to partially ordered set, lattice, and after lattice we will just define what is Boolean algebra. Boolean algebra is a lattice having these property: absorptive, associative, self-complementary and absorptive property. So that's why this property is very important. Many times we miss this, but you remember this thing, that A intersection and then this operation and this operation are different, then that is, it is absorbed. Absorption is there. Clear? Okay. Membership table we have seen. So for example, if you have to prove, there also if you have to prove something, this is not for GATE, but you should understand that if you have to prove two table, and sometime in GATE also there is some options where you have to check finally that both sets are same or not. In that it will help. How to make this same as truth table? You understood this? It is like truth table only. And if truth values are same, it means both set are same. So like that you can do this also. Like addition means like addition we are writing sigma of something. Similarly here also we use big union notation for an array union, okay, and similarly big intersection notation for an array intersection, okay. Same like addition and multiplication. Why I am telling union as addition and intersection as multiplication? Yes, you understood this logic. Here also plus is union and dot is intersection. So that's why both will be similar thing, okay. Now I'll check, I'll write one thing. You have to check, let a at the rate b equal to a plus b minus ab. Let this is one operation. Can you check that this operation is associative or not, distributive or not, and absorptive property satisfied or not? At the rate is a imaginary operation. Meaning of that is a plus b minus ab. Ab means a dot b. So can you check it is associative or not? How to check? How to check associativity? No, associative means you have, okay, you have to take at least three things, then only you can do bracket. So you have to take third thing. For example, if I am taking a at the rate b, so you have to calculate this, and then you have to calculate that is it equal to a at the rate b at the rate c, both are same or not. If both are same, then this is associative. Is it clear? So you check it for that operation. At the rate is what? A plus b minus ab.
So you have to check with C.
Yes, for both sides. For example, here it will be what? A plus b minus ab and then at the rate c. So now this will become what? A plus b plus, or a plus b plus c minus ab, means a plus b both, and then minus this into this. So this will become A plus B minus AB into C. Is it clear? This is what? It is better that you, if you are confusing. A plus B minus AB plus C. Is it clear now? This is A and this is B, and this is at the rate. Meaning of at the rate is this one. This is already defined in the question. What is at the rate? At the rate is an imaginary operation, and it is defined that A at the rate B equal to A plus B minus AB. This is given. Now you have to tell that this operation is associative or not. So how you check? First you will for checking associativeness, you must have to take third element. Without third element you cannot check associativity, because for associativity you have to check the bracket. So for bracket you have to do this thing. So now you calculate it.
How, like A plus B minus AB at the rate C?
This one. So first we do
Yeah,
this.
I understood. The third step.
Then what happened? This plus C. Now this is A and this is B. So this whole thing is this plus C. Now this whole thing multiply with C. And this whole thing multiply with C, and here minus will be there because here it is minus AB. Now do it. So this is what? A plus B plus C minus AB minus AC minus BC plus ABC. Now do for this part also. So same. So it means this at the rate operation is associative. At the rate operation is commutative or not? Why not?
No, yes, commutative.
It is commutative. Why? Because A at the rate B equal to B at the rate A. So it is commutative. This operation is associative and commutative. Is it absorptive or not? Okay, 1 minute. That cannot be checked because for absorptive you need two operations. Okay, so it cannot be applied for absorptive. Absorptive property will be satisfied with two operations, two different types. For example, union and then intersection, plus and then dot. Is it clear? So now at least you understood these all of what mainly you understood, what is set, how to count number of subset, that you understood. Means actually you have to choose combination and then power set. Okay, one important thing, sometimes they ask, for example, if this is a set A, B, C, this is a set, okay, and now it is asked that A is subset of A. Is it correct? I am asking again, is it correct? This is not correct. A is element of this set.
Okay, no, sorry.
Okay, so if it is like this, then it is correct. Is it clear? So you have to understood the difference. A is element of this, but if it is set, then only it is subset of something. Is it clear? What if I'll say A is subset of this? Is it correct? Again, what is power set of A? Those many elements, but what are those? That is a set containing this. Means phi is an element, A is also an element, okay, but A is not an element of this power set of A. Yes, can we write this? A is element of power set of A. Yes, okay. A is element of this, but what is power set of A? Power set of A is this one, means 2 raised to power A is this one, phi A, B, C, AB, BC, CA, ABC, 2 raised to power 3, 8 elements. Yes. So now,
No, that's wrong.
correct. So this is wrong. Is it clear now? Actually, this A is element of power set of this. This is an element, but that is not subset. Is it clear now? That is not subset of power set. And if I'll say that, similarly, if I'll say this A is element of this,
No.
this is also wrong. But what about this?
It is.
It is. What about this?
No.
No. But this is correct. Okay? Means if you do double bracket, then definitely it is in power set.
Double bracket means?
Means I am telling this thing. This statement. This statement is correct? This is wrong? Tell me.
What is a double bracket?
Yes, double bracket means set of set. Because here also double bracket is there. One bracket is here and inside,
Okay, then it's correct.
then it's correct. Is it clear? Similarly, if I'll say that this, correct. So you understood the meaning of element and subset. Okay? Okay. So yes. So you understood number of and you can count number of element also, how many elements will be there.
It's given by 2 to the power n.
2 to the power n for total number. Okay. So today generalized intersection, that is, so today I'll keep here only. Okay. Next day we'll do relation, and then some counting problem. Actually after set, relation, function, then we'll do get problems of related, because for only set they will not make question, because set is very although very simple, but it will be mixed with other thing, then only get questions will be there. Okay.
So you will complete the syllabus and then
No, not whole syllabus, but set, relation, function, 3 things. Then I'll do questions of get related to set, relation and function. Then again I'll go to other topic. Okay.